Heyo, grade 10 advanced science. How's it going? So we have our first video that we're going to do for our new topic of types of reactions. So there's going to be a few videos. There's going to be one just me here introing what these reactions are, what they look like, what they kind of mean. And then there's going to be a couple videos of me actually going through some of the practice work. And I'll have the practice work actually projected up here, and then me going through them, how I think and process through those questions, how to answer them, and all that kind of stuff. But let's go through and actually intro what types of reactions. So these are chemical reactions. Anytime we think of what like a type of reaction, these are types of chemical reactions. And again, in grade 9, you kind of went through different reactions like, again, what is a chemical change? And that's something that changes our actual products and reactants in the sense that there's something different from before and after. And so we have 5, kind of 6, and we'll sneak that 6th one in later next week. But there's 5 major different types of reactions. And they are, and I guess before I start saying this, when we're going through these videos and you're kind of going through these online videos, which is me right now standing in front of you at a board, and you can't really ask me questions, what I would suggest doing is I would suggest actually kind of taking notes from this video. And then I have another video, actually one done by Tyler DeWitt, who's an online science person that does really, really awesome videos. And I have that as well, that link in the helpful videos. That's probably right beside this one. I would look at that if you need some further clarification, and again, take some notes on a paper of kind of what these reactions are, what we're kind of saying. That way, when you actually go into the work, you have something to kind of look at as you go through. Because if you're just watching this video and then after the 10 minutes of this video are up, and you're like, cool, and then you go to the work, there's nothing in front anymore. So I would say take a little bit of notes kind of as we go through this. It'll get you into good habits of when you are trying to purposely watch educational videos. Again, take notes is a good idea. So here we go. Let's actually go through this. And again, the nice thing is you can pause this and do whatever you want, rewind it. So our 5 different types of reactions. We have combustion, okay, synthesis, decomposition, single displacement, and double displacement. Okay, I know they're small on the board, and they're kind of hard to see. I'm going to kind of go through each one of them right now and write it hopefully a little bigger. Okay, so let's start. Number 1, combustion. Combustion. Hopefully I spell these right as we go through. All right, combustion. What is a combustion? Well, the thing that I just see we have a really bad glare. Wow, from the light that's behind. I'll try and get it in between the glare. My bad, class. Combustion. Is that better? Hopefully that's a little better. I'll try and make sure that we stay there for most of it. Okay. What a combustion means, it is, and it kind of sounds like this, like combustion happens in a car. Combustion happens in a lot of things. What it means is that they're hydrocarbons, and I'll stop right there. What is a hydrocarbon? Hydrocarbon is hydrogen and carbons together. That's it, so C and H's. So if I have C3H8, that is regular gas. Okay, that is a hydrocarbon. It just has hydrogens and carbons together, and it combines with oxygen, so it combines with oxygen, and it creates like a combustion reaction, a lot of heat, a lot of energy. This is the same kind of combustion that happens in a car or in a plane or in anything kind of engine, small engine, like a lawnmower. You basically take some kind of gas, you add oxygen, and then you can you put it under heat or pressure, and you get a lot of energy out of it. That's why your car can move. That's why a lot of the engines are able to do things. And what it creates basically just H2O plus CO2 and energy. Okay, so you can kind of see like we have C, H, and O, and that's all we have here. O, C, like C, H, and O, just in a different, again, pattern, and we get a lot of energy out of this. So this is what a combustion reaction is. It's when you have hydrocarbons, C and H's, combining with oxygen, and you get water, carbon dioxide, and a lot of energy. Okay, and so you'll be able to recognize this reaction just because of that hydrocarbons, and we get a lot of water and CO2 at the end. Okay, so there's our first type of reaction. This is kind of what I would say like as an outlier. The only way to really recognize this one is just by those lots of hydrocarbons. Okay, the other 4 have some kind of rhyme or reason that we can kind of look at when we think of an element or a compound. So number 2 is a synthesis. And this is when two elements, two pure elements on its own, combine to make an actual compound, okay? So I'm going to just put it down like if I have hydrogen and oxygen by itself, they combine to make water, okay? And I'm going to kind of write this in a different way here. I'm going to put down like an A and a B that are separate, their own separate little elements, and this works with any kind of element. If you have one element and another element, and they combine, that is a synthesis reaction. Two simple things combine to make a compound. And so it was A and B separate, and at the end it is A and B together. Okay, one element, another element, they combine to make now a compound. They're now actually physically bonded into a compound. And so that is what a synthesis reaction is. Okay? All right, moving on. Number 3 is kind of the opposite of this. We'll call it, number 3 is a decomposition. Okay? So a decomposition. This is kind of the breaking apart. Like I said, the opposite of synthesis. So let's kind of start with magnesium oxide. Magnesium oxide. Okay, magnesium oxide, MgO, that is a compound. Now what I can do to magnesium oxide is I can actually rip it apart with just a little bit of heat. Okay, that's like that magnesium burning. What I can do is I can turn this into magnesium by itself and oxygen by itself. So what a decomposition is, it is a compound that then turns into two like elements on its own. Those elements are now pure and on their own. They're separated. They're no longer together with this compound here. Okay? And so we can kind of look at this as the opposite of synthesis. This is where an A and a B element were together. And then in the end, it is A by itself plus B by itself. I'm just using these letters as like, again, an A element and a B element are together in a compound, and then they're separated over here. Here I actually use my real elements. Okay, so that is a decomposition. That's a decomposition one. All right, those first 3 hopefully are pretty easy. The last 2 are a little tougher because there's some steps that we have to look at. Let's go through. 4 is a single displacement. All right, for this one I would suggest maybe making sure you have your periodic table beside you. So if you need to pause, go to your periodic table, I would suggest doing that right now. All right, so for a single displacement, this is where we have one compound and one element at the start. So I'm going to start with a lab that I actually want to do with you when you come back next week is silver nitrate. So Ag and nitrogen plus, and then just copper, Cu. Okay, and we're going to talk. So we have one compound. Okay, here we have a compound, 2 things together, and we have one pure element. Okay, so this is what we start off with at the start. Now, what it's going to turn into is it's still going to turn into one compound and one element. But how do we know what's going to switch? This is where you have to know our metals and our non-metals. We are going to look at the element that's by itself. Copper is a metal, so it's going to switch with the other metal in this. And so silver is the other metal in this. And so what's going to happen is what comes out at the end is we get copper nitrate. That's a U, not a 4, my bad. Copper nitrate and silver all by itself. Okay? So we had a compound and one element at the start. We still have a compound and one element in the end. But what switched is this one, the metal switched, because the one all by itself was a metal. Okay, I'm going to give you one more scenario where it's similar but just a little different. Let's go with hydrogen and chlorine. So like basically HCl, hydrochloric acid. And if I actually combine it with sulfur, this is going to turn into something different. I have my hydrogen right now is going to be kind of actually our metal. Okay, and let's make this a little easier. Let's make it lithium chloride to make it a little easier. Okay, we'll make it lithium just to make it very simple. This is a metal, this is a non-metal, and sulfur is a non-metal. So this is our before. We have one compound, and we have one, this should have this, and we have one also non-metal here. Compound, element, this is a non-metal. Well, this non-metal is going to switch with a non-metal in this one. And that's what's going to pop out. It's still going to be one compound over here and one element. But our sulfur and our chlorine are going to switch because that's a non-metal, this is a non-metal, and so they're going to switch. So it's going to be LiS plus chlorine. Okay, we'll talk about these numbers in a little bit. Just for now, we just need to know how they're going to switch. Okay, so in a single displacement, we have a compound and an element. At the end, we still have a compound element, but you have to make sure like what switches. Either it's a metal with a metal or a non-metal with a non-metal. Depends on what's by itself at the start. Okay, in here it looks like this. We have an A, B plus a C, and it turns into A and C plus B. So we can kind of see that switch. So if we want to use our letters as an example, we had an A, a B, and a C, and now our C switched with one of those. Okay, so that is going to be a single displacement, where a single element is switching with another one. All right, let's go to the last one. Last one, number 5, is a double displacement. And this is going to be when we have two compounds and some things swap. So let's go with magnesium oxide, and let's go with lithium fluoride. So we have a compound and a compound. Okay, magnesium and oxygen go together nice in an ionic bond. They're 1-1. Lithium fluorine as well, nice 1-1. Okay, so this is a compound and a compound. Well, what's going to switch here? At the end, we're still going to have a compound and a compound. Okay, so we're still not going to have any elements on their own. We're still going to compound. But the metals here are going to switch. Or if you want to think of the non-metals can switch, I just like to think the ones at the start are going to switch. So magnesium is no longer going to be with oxygen. It's going to switch and be with fluorine. And lithium is going to switch and go with oxygen. So the metals are going to kind of switch spots. So I'm going to take Li and put it with O at the start. So it's going to be Li to O plus MgF. And so I can now see that the Li is with O and the Mg is with F. And so that is a double displacement. Two things switch. And the nice thing is, like single displacement, you have to look at which one you're going to switch. Double displacement, super easy. Switch your metals, all done right away. Okay? You'll notice that I had no letters here, no numbers here, and now I have numbers here. Okay? When you're doing these different kind of reactions, you're going to have to make sure that we kind of remember ionic bonds. These are all basically ionic bonds. And so you kind of have to go back and remember like ionic bonds. How does Mg and O go together? Well, Mg and O go together 1-to-1. How does Li and F go together? Well, 1-to-1. How does Li and O go together? Well, I need two lithiums to make the oxygen, that makes the compound. And then this one, Mg and F, how do I make those two together? Well, I need two fluorines to make sure. So we're going to have to kind of remember ionic bonding, but that's the reason why I have numbers here and not here. It's not because I just magically made up, it's how they actually bond together. Now you notice here, they're not balanced. Guess what? I'm not going to make you balance them. Okay, we're not going to worry about that at all right now. We just want to know how these things come together. Okay, and so that is our last reaction of a double displacement. So we have combustion, which is a lot of hydrocarbons with oxygen. They make water, CO2 energy. Then we have a synthesis, two elements on its own come together. Third one, decomp. It starts together as a compound. They split apart. Single displacement is where just one element sneaks in and switches with, like, it's either same metal or same non-metal, but one element switches with a compound. And then our double displacement is where we have two compounds and the metals switch, and you're still left with two compounds. Okay, so there's your little intro. Hopefully you got some good notes of this. You can watch the Tyler DeWitt one as well. He goes through the same 5 in a very similar fashion, but sometimes a different voice is just nice to hear. Okay, so there's an intro. The next couple videos will be me actually going through the practice questions, going through how to do them. The answer key will already be up there. And then again, like I said, there'll be one little assignment at the end based off these kind of questions. Okay guys, if you have any questions at all, message me. We can have a quick little message, like a chat, or we can have a quick little video at any point. I'm in school Monday to Friday. Yeah, but hope this goes well. Thanks, class.